Hey, sixth graders, Mrs. Simonson here. Tonight we are working with ratios. We have two objectives. The first is to identify and use ratios to compare quantities, and the second is to apply the relationships between ratios to solve problems. So let's go ahead and get started. First thing we need to know is, what is a ratio? A ratio is simply a comparison of two or more amounts written in the order the data is given. That's really important to note because the order the data is given is very important in ratios. You can't switch up orders. Ratios can be written in three different ways or three different forms. The first is with the word to, the second is with a colon, the third is as a fraction. So let's say I'm eating snack one day and here's kind of an arrangement of snacks. I have cashews and pretzels and I want to know what is the ratio of cashews and pretzels. So first it's important to note the order. Cashews number would always come first, followed by the pretzels number. So I can write it using the word to, 10 to 4, the ratio of cashews to pretzels. I can use a colon to write the number, 10 colon 4, or I could write it as a fraction, 10 over 4. So we're going to get you started right away. Please complete problems number 1 and 2 in your math notebook and press play when you're ready to check your work. In addition to having three different ways you can write a ratio, there's also three types of ratios. The first type is part to part, the second is part to whole, and the third is whole to part. So now we'll have Mr. Hansen. He's got a snack mix of cashews and pretzels, and we're going to show different ratio types using that snack mix. So the first type was part to part. He has two parts in his snack mix. He has cashews and pretzels. So if I wrote the ratio of pretzels to cashews, that would be part to part. The second type is part to whole. So let's continue with the pretzels. He has 4 pretzels, but then for the whole, I want to think about how many items are in all of his snack mix. Well, I've got 10 cashews plus the 4 pretzels. The whole would be 14. So the ratio of pretzels to his snack mix would be 4 to 14. And then the last one, whole to part's pretty simple. It's just flipping the one we had just done previously and putting the whole first. So 14 represents the whole of Mr. Hansen's snack mix, while 4 represents just the pretzel part of it. So again, another chance for you to practice. I want you to write each of these statements as a ratio and then code what type of ratio it is. If it's part to part, use a double capital P. If it's part to whole, use a capital PW. And if it's whole to part, please use a capital WP. Press play when you're ready to check your work. Ratios can also be written as equivalent ratios. Those are simply ratios that name the same comparison. And we use the same steps that you learned in Module 2 for equivalent fractions to find equivalent ratios. So here I have that snack mix again of 10 cashews to 4 pretzels. If I look at that as a whole, I could use the ratio 10 cashews to 4 pretzels. But I can look at this arrangement a little bit differently. Instead of thinking of my 10 cashews as a whole, I could divide them into 2 equal parts of 5. And then I can take my 4 pretzels and divide those into 2 equal parts of 2. So to find an equivalent ratio, instead of looking at my snack mix as a whole, I'm going to look at it in parts. So I could say this ratio is the same as 5 cashews for every 2 pretzels. To find even more equivalent fractions, so that one I used dividing. I divided it into different parts, but we know from Module 2 we can also multiply. So what if I added to my snack mix another 5 cashews and another 6 pretzels and looked at it as a whole? Well, then I can see that I have 15 cashews to my 6 pretzels. And if you notice, from here to here and here to here, I'm multiplying first by 2, and then 5 to 15 is by 3. 2 times 2 is 4, 2 times 3 is 6. So again, using the same method we used for equivalent fractions, we can find equivalent ratios. So now it's your chance to practice. Please solve number 6 and 7 in your math notebook. Press play when you're ready to see the work. Depending on if you divided by a common factor or multiplied by any whole number, you would find an equivalent fraction. And because we might have all chosen different numbers, for both of those answers are going to have to vary, and we'll just check them when we check your math notebook. All right, the last thing we need to work on is using that knowledge we just gained to solve problems with ratios. And it's really 2 steps. First, identify the type of ratio you're working with, and then find an equivalent ratio. Most often, when you find the equivalent ratio, you're finding the number that the problem is wanting you to. So let's do one together. The first example, Mr. Hausman downloaded rock and pop tunes to his iPod Touch in the ratio of 1 to 8. He has 5 rock tunes. How many pop tunes does he have? Well, the first thing we need to do is find the ratio that we can use, and that's 1 to 8. The 1 represents the number of rock tunes, the 8 represents the number of pop tunes. So out of all of his music library, these are each a part of them. So it's a part-to-part ratio. What they're wanting us to find then is, what if he had 5 rock tunes, how many pop tunes would he have? And so the equivalent ratio they're wanting us to find is also a part-to-part. So now we can balance our equivalency. What can we do to the 1 to make it a 5? Well, we can multiply it by 5. So we multiply the bottom part of the ratio by 5, and we can find out that the question mark that we're finding is 40. Go ahead, try a problem like that in your math notebook. It's problem number 8. Work it in the notebook and then press play when you're ready to check the work. Let's try another problem together. There are 24 coins. 1 out of every 6 coins is placed heads up. The rest are tails up. How many coins are placed heads up? Well, here's the ratio they want us to work with. So 1 to 6. The 1 represents a number of coins that are heads up. The 6 represents the whole collection of coins we have. So this is a part to whole. And they're wanting us to find out, if we had a collection of 24 coins, how many would be heads up? So again, they're wanting us to balance a part to whole. So we just simply think, what can we do to 6 to make it 24? Well, we multiply by 4, and so then 1 times 4. Our answer would be 4 coins out of a 24 coin collection would be heads up. Try one like that in your math notebook. It's number 9, found at the bottom of the screen. Press play when you're ready to check your work. The last one is probably the trickiest one, so let's work this one together. There are 2 iPads for every 7 iPods. If there are 36 devices in all, how many are iPads? So let's start with the ratio that they give us. 2 iPads for every 7 iPods. So if we think about a collection of devices, the 2 is 1 part of our collection, and the 7 is 1 part of our collection. So it's a part-to-part ratio. What they're wanting us to find is a ratio. If we have 36 devices in our collection, how many are iPads? This part is a part to whole. So we can't use our part to part to then find a part to whole. We need to change this one to a part to whole. And it's actually quite simple. If we have 2 iPads and 7 iPods, we have a collection of 9 devices, 2 of which are iPads. This is now a part to whole, and we can use it to find our answer. What do we do to the 9 to make it a 36? Well, we multiply it by 4. So we do the same to the top part of the ratio, and we find that we have 8 iPads in a collection of 36 devices. All right, now try this last one, number 10, in your math notebook. Press play when you're ready to check your work. Alright, that was a lot of information packed into the video, but very important information, as ratios are one of the most important standards for the 6th grade. Review any part of this video that you need to. And when you're ready, take your quiz at Schoology, and we will see you next time.